What you are looking at is a pristine, fully cured orthopedic cast, a rigid, impact-resistant shell built onto a patient's limb to perfectly stabilize fractures. To construct this structure, clinicians rely on a highly specific instrument, the Orthoplast Plaster of Paris Bandage by Cotton Craft Pvt. In this detailed breakdown, we will walk through the exact steps required to activate, apply, and mold this material correctly. The procedure requires two strict prerequisites before you begin. First, the patient's targeted limb must be fully wrapped in protective padding. Second, you must prepare a basin of clean, room temperature water. You also must strictly control the environment. Plaster of Paris, chemically known as calcium sulfate, is highly reactive to moisture. If an unsealed roll is exposed to high ambient humidity, the plaster will harden in the ambient air, rendering the bandage useless before it ever touches the water. Keeping all the materials completely sealed in their moisture-proof packaging until the exact moment of use prevents this premature hardening. Mastering these initial environmental variables gives you the stable foundation required to build a secure cast. This matrix diagrams the first step of the procedure, selecting the correct tool for the patient's anatomy. Orthoplast comes in lengths of 2.7 meters, but you choose the appropriate width, 5, 7.5, 10, or 15 centimeters, to match the injured limb. Once you unseal the package, you will find a specialized high-quality lino weave cotton gauze that has been thoroughly impregnated with the calcium sulfate formula. To activate the chemical reaction, you must submerge the entire roll into your water basin at a precise 45-degree angle. This angle allows the water to penetrate the layers evenly. The bandage is engineered for a low soaking time, meaning it absorbs water rapidly. As it saturates, air bubbles will rise to the surface. The moment those bubbles stop appearing, the roll is fully saturated and ready for extraction. To remove the roll, lift it clear of the basin and gently squeeze both ends inward toward the middle of the bandage. This removes the excess water while keeping the structure intact. A common critical error is twisting or wringing the roll like a wet towel. You must avoid this completely. Twisting forces the plaster compound out of the gauze. Orthoplast is engineered for minimal plaster loss, meaning the formula grips the cotton weave during the soaking process. By squeezing gently toward the center, you retain the maximum amount of plaster on the actual bandage, rather than washing it away. Maximizing the amount of active plaster on the gauze is exactly what dictates the final strength of the cast. Precise water activation guarantees a robust structure. With the bandage activated, immediately unroll it directly onto the padded limb. Apply it smoothly, allowing the wet plaster to conform without pulling or creating excessive tension. This cross-section shows the required geometric rule for application. As you spiral up the limb, every new layer of bandage must overlap the previous layer by exactly 50%. When executed correctly, this 50% overlap creates a uniform wall of wet plaster with absolutely zero gaps. The moment the wrapping is complete, you immediately begin the friction-based molding phase. You have a limited window of time to shape the cast to the patient's anatomy. By firmly rubbing the external layers together, your hands activate a specialized creamy texture inherent to the Orthoplast formula. The distinct weave of the gauze melts away into a smooth, malleable surface. You use this creamy state to mold the cast firmly around difficult body contours, ensuring a custom, therapeutic fit for the specific injury. Cautionary: during this molding phase, you must never use your fingertips to press the wet plaster into shape. On the right of this split-screen diagram, fingertips create hazards by pressing sharp dents into the plaster, compressing the padding into permanent pressure points against the bone. On the left, using flat palms distributes force widely, forming a continuous, safe inner wall. Maintaining strict palm contact ensures the cast correctly supports the limb without causing localized internal pressure injuries. As you finish the molding, the patient's limb must be held perfectly still in the desired anatomical position, while the chemical reaction completes its initial setting phase. In this time-lapse, you can see the results of the fast-setting formula. The glossy moisture flashes off, turning the plaster matte and rigid. This accelerated timeline is intentional. It allows healthcare professionals to stabilize the fracture rapidly, drastically reducing the amount of time the patient has to endure the discomfort of an unsupported injury. The rapid transition from a moldable, creamy paste into a rigid architectural support successfully locks the limb in place, completing the primary immobilization procedure. Externally, the cast is now a highly durable immobilization device, fully capable of protecting the limb during the weeks of required fracture healing. However, the curing process is still occurring internally. It takes a mandatory 24 to 48 hours for the moisture trapped deep within the internal layers to completely evaporate and dry out. During this drying window, the patient must avoid resting the cast against any hard edges, like the arm of a wooden chair or the edge of a table, as the internal layers are still vulnerable to late-stage structural deformation. By managing the patient through this final curing window, keeping strict control over the manual application steps, and ensuring all unused Orthoplast rolls remain sealed in climate-controlled storage, you can consistently deliver rapid and reliable orthopedic stabilization.